Okay, here's the gas law lecture. We're going to be taking an ideal gas, and we are going to be studying how changing some of the variables associated with that gas, the volume of the gas, the pressure of the gas, the temperature of the gas, and the number of moles, how that affects the gases. And it works for all gases, no matter what they are composed of. They all react in the same fashion. Mr. Avogadro noticed a relationship between volume and pressure. He noticed when he changed the volume, the pressure responded, and he was able to find that that response always came up to the same number, a constant he called K. Mr. Boyle then took that relationship and wrote Boyle's law. He said that if you take a gas at a certain volume and pressure and change one of the variables, you can figure out the other variable. So his law, V1P1 is equal to V2P2, it describes an inverse relationship. That means that as one variable goes up, the other variable goes down. So if the volume is expanded, the pressure will decrease. Graphically, that looks like the graph on the left, where it is an inverse relationship with a parabolic shape. As the pressure goes down, the volume goes up. Now, we'll talk about why during our kinetic molecular theory adventure. Now, a lot of people don't like to work with a graph that's nonlinear, so other folks figured out if you graph pressure over the inverse of the volume, you get a nice straight line, and that straight line goes through the origin, so you're able to extrapolate based on the graph. That's a very handy thing to do if you only have the graph and no numbers. Okay, I'm going to do the problems at the end because I am just going to. Now, the next thing that we're going to talk about is Charles's law. Charles's law is relating temperature and volume. I guess I'm going to hold this. Now remember, you must use temperature in Kelvin, otherwise you're going to be sorry and wrong. People have probably already figured out the Celsius scale has negative numbers, and if you put a negative number here, you could possibly come out with you would come out with a negative volume. It is impossible in our universe to occupy negative space. Okay. Charles' law has said that when pressure and the number of moles are kept constant, the volume will directly be related to the temperature. That means when the volume goes up, the temperature goes up. When the temperature goes down, the volume goes down. Graphically, it looks like this straight line. Now, those clever among you will also notice that this goes through the origin. This temperature is in Kelvin. We all recognize 0 degrees Kelvin as absolute zero, and at absolute zero, the volume of an ideal gas is 0. Okay. Now, some people think that Mr. Avogadro got cheated because he did not get his work noted in Boyle's law. Well, here he goes. He has his own law. It's called Avogadro's law, and he says that the volume of a gas, when the temperature and pressure are kept constant, is directly proportional to the quantity of gas. Okay, the picture says it all. Each one of those balloons holds 1 liter of a different gas at 25 degrees C and 1 atmosphere. Each balloon holds the same number of moles of their gas, so the same number of particles of gas, and the volume is the same. No matter what the gas is, with the same number of moles, the volume is the same. Here it is, V1N1 is equal to V2N2. Now, you may have figured out that when you have a relationship where one variable is divided by another, that denotes a direct relationship, and it is the same here as well. You increase the number of moles of gas you have, and the volume will increase. Here's a relationship between the number of moles, N, and volume. Let's take a small balloon, and let's say you filled it with some of your air. We'll call it student gas. And it occupies a space. It has a certain volume. You add more gas particles. In other words, you put more student gas into it. There are an increased number of collisions with the wall of the container. That means an increased force of collisions inside. The inside pressure of the balloon becomes greater than the outside pressure of the balloon, and so the balloon expands. This is not rocket science. All right, the last thing that we need to talk about today is the ideal gas law. The ideal gas law is one that no kid in my class has ever forgotten. In the history of my teaching career, please do not be the first person to do so. Like the t-shirt says, the ideal gas law is PERV-NERD. Pressure times volume is equal to the number of moles of gas times R, the gas law constant, times T. I'm going to warn you now, the gas law constant can take any form depending on the unit of volume, pressure, and temperature. Well, temperature has to be K, so let's pretend that I didn't say that. Volume and temperature. You want to make sure that you only have to memorize one. So I'm going to harp on you the liters, Lattmann-Moltke units that you need to use when using the ideal gas law. There is another unit of R that we will use when we need to talk about energy. Right now, Lattmann-Moltke is the value of R for you. Alrighty, please stay tuned for the pencast of these problems.